let's consider an interesting case where if I have a device now that is basically um, this tube where I have an area A1 and an area A2 on it, but these areas are different. So let's say A1 is less than A2. So I have a smaller opening on the left-hand side and a larger opening on the right-hand side. And now I fill this with a fluid. So I put some fluid inside here. And then what I do is I apply a force. So let's say I apply a force F1, which pushes down the fluid, and it's going to push the fluid down by a distance D1. So I'm going to decrease the height there, which actually raises up the fluid a distance, let's say D2 on this side. So the fluid goes down on the left-hand side and then goes up in the right-hand side. Now, if I apply a force on the left-hand side, that means I have a pressure, but the pressure should be continuous throughout the system, so I should get a pressure on the right-hand side, which means I should get a force pushing up on the right-hand side. So a force pushing down on the left pushes on the fluid. The fluid then moves through the container, and its only escape is on the right-hand side. And so therefore it's now going to push back on the right-hand side with a force F2. So I can push down on the left and basically transmit that force over to the right. So now if I plug this in, the pressures are the force 1 divided by area 1 is equal to force 2 divided by area 2. And if I multiply both sides by area 2, then I get force 2 is equal to area 2 divided by area 1 times force number 1. Now I said that area 2 is much bigger than area 1, therefore force 2 should be bigger than force number 1. So I've now made a device which basically multiplies the amount of force that I have. So if I apply a force of 10 newtons on the left-hand side, so let's say F1 is 10 newtons, and area 2 is 10 times area 1, then when I put this all together, I should now get a force, F2, which is 10, cancel the areas, times 10 newtons. I should get a force of 100 newtons. So I've multiplied the strength of the force coming out by a factor of 10. So that's pretty good. So now if we want to lift something up, we don't have to necessarily use just our brute force, but we can use this device which can actually multiply the force, and we can pick up much heavier objects than we would be able to if we had to just do it with our brute strength. So this was what makes things possible, like brakes in your car. So there is a fluid, there is a brake fluid, a certain type of oil, which has a certain density, and then you apply a force to the brake pedal. The brake pedal compresses, it pushes on the fluid, and if the area on the other side where the brakes are is bigger than the area in the container where you're pushing with your brake pedal, then you can apply a much larger force than you would be if you just took your foot and pressed it against the wheel and tried to apply a brake to it. So you usually see these things in like pneumatic brakes in cars and trucks and trains. You see them in devices like cranes, where they're using a piston to try and pick up very heavy objects. Now there's no such thing as a free lunch, and so what you see is that if I was to draw the system again, by making these two sides different shapes, basically what I'm doing is playing around with the ratio of the areas, but the volume, so let's say this volume here, volume 1, is now going to be equal to the amount of volume over here in volume 2 that's displaced. So the displaced volume on the left has to be equal to the displaced volume on the right. So volume 1 is equal to volume 2, which is area 1 times the distance 1, which is equal to area 2 times the distance 2. And therefore, the distance 2 causing the displacement, or that the amount of displaced fluid, is distance 1 times this ratio A1 divided by A2. So I basically divided both sides by A2. And so in this case, since A1 is smaller than A2, that means distance 2 is going to be smaller than distance 1. So if we go back to our case, if let's say D1 is 10 centimeters, but area 2 is 10 times area 1, that means the displacement D2 would be 10 centimeters times the 1 over 10 you get from the area ratio, or 1 centimeter. So while I now be able to apply a force of 100 newtons on the right-hand side, I'm only going to be able to move that object 1 centimeter. So I'm only going to be able to move the object a fraction of the distance. So you either now have to have a very large distance on the left-hand side, or realize that you're not going to be lifting up this object very far, but maybe a centimeter is all you need to pick up a refrigerator and move it across the room. And so you still have the mechanical advantage with this system.